Trigonometry, lesson 6.2, trig functions and the unit circle introduced. So, draw a right triangle and pick one of the two non-right angles, and off we go with sine, cosine, tangent, cosecant, all that fun stuff. So out here I'll throw it. Call this angle A. That is opposite. This is always hypotenuse. Hypotenuse is across from the 90. Opposite is across from the angle. And this is adjacent. So sine of A is SOHCAHTOA, for those who don't know this. Sorry. Doing this a little bit backwards. Sine is opposite over hypotenuse. It's also 1 over cosecant. What's cosecant? Cosecant's 1 over sine, which is hypotenuse over opposite. Cosine's adjacent over hypotenuse. Therefore, secant is hypotenuse over adjacent. And cosine is 1 over secant. Secant is 1 over cosine. Tangent is opposite over adjacent. Therefore, cotangent is adjacent over opposite. And by the way, of course, we're supposed to use real numbers in here. But now I'm just giving you the lay of the land. Adjacent's the one next to it. That's not the hypotenuse. So, you got the idea. I would pause this and see if you can do it. I like to do them like this. It's much easier, but different strokes for different folks. Whatever works for you. So sine of A is opposite, and a lot of people like to go and label, which is not a bad idea. Remember, hypotenuse is always across from the 90. Boy, do we get problems with that. Sine of A, 3 over 5. Cosecant, 5 over 3. Cosine of A, 4 over 5. Secant of A, 5 over 4. Tangent of A, 3 over 4. Cotangent of A, 4 over 3. So that's your 6 basic trig functions. You've got to know how to do them all, and you've got to be ready. Quick review. 2 special right triangles. Got the 45, 45, 90. And we got the 30, 60, 90. I'm going to derive them here, but I'm going to do it fairly quickly. 45, 45, 90 is fairly easy. Since it's 45, 45, these sides are the same. We're just going to call them x. And if we sat down and did Mr. Pythagoras, x squared plus x squared equals hypotenuse squared, we would get the square root of 2x squared, which is just root 2x. And we typically write that the other way just because we do. I'll give you examples of this in a minute, but it's that simple. If I give you a leg of a 45, 45, 90 is 6, the other leg is 6, and the hypotenuse is 6 root 2. You could easily do the Pythagorean theorem, but the point here is that it pops up often. Let's find a shortcut and let's buzz through it quickly. 30, 60, 90, a little trickier. Got to take a equilateral triangle, bust it down the middle. I'm going to erase this side, and I'm going to solidify this. So if this was an equilateral, that was 60, and since we cut it in half, that's 30. Well, we knew that this whole side we'll call 2x is the same as this side. and we cut it in half, so this is x. I'm not going to do it, but if you did Pythagorean theorem, you'd find this is x root 3. So how do we remember this? Hypotenuse is the 2x. I like to call this the short side. It's across from the 30. And I like to call this the long side, because it's across from the 60. Notice hypotenuse is always hypotenuse. Again, people get lost. Oh, well, the longest side is the hypotenuse. Hypotenuse, hypotenuse. Long side is its own thing. So, here's a bunch of examples for you to try. First 45, 45, 90s. I would pause this and try it yourself, because I'm going to do it right away. This is also 45, therefore 12 and 12 root 2. This one's tricky. We multiply by root 2 going one way, so here we're going to divide by root 2. So you get 8 over root 2, which any good math teacher will tell you cannot leave it like that. Root 2 over root 2. 8 root 2 over 2, which is 4 root 2. Now, I'm not a big fan of doing it this way. I like to kind of guess and check. So it's 4 root 2. Multiply that by root 2, and that's how we go this way, times root 2. Oh, we get 8. Nice. And of course this is the same, 4 root 2. 7 root 2. 7 root 2 times root 2 equals 14. Sure hope you know that root 2 times root 2 is 2. Root 2 times root 2, I get a lot of people do this. That makes me a little insane. Just jump to the 2. Same thing, same thing. We get 2. I always like to teach it. Square root of Bob times square root of Bob is Bob. So you don't have to do that whole, well, square root of 2, square root of 2. It's an extra step. It's just going to lead to mistakes. And here we just have 10 and 10. Now the slightly trickier ones. 30, 60, 90. 30 is 6. Let's go this way, we slap root 3 on it. Let's go this way, we double it. Done. Notice it's just making it simpler. I don't have to go back and think about, oh, well, this is a equilateral triangle, therefore this is 6, therefore this is 12, and then a squared, b squared. You don't have to do all that. 30, 60, 90 rules save you. If you're one of those people who just kind of, just kind of slaps your way through and, I kind of figure out what I'm doing, it's going to get you. You got to know your 30, 60, 90s. Got to know them cold. This is a little tougher. To go this way, we divide by root 3. So this is 8 over root 3, which I just did before. 8 root 3 over 3. Take that and double it to get here, so it's 16 root 3 over 3. We don't double the 3, we don't double the root 3, we just double the 16. Algebra skills, algebra skills, algebra skills. Don't know if this is 30, 60, 90, but since it's half from here to here, we just figured out it is. It makes this 30 and this 60. It makes this 9 root 3. Now I've already done these problems. I've already seen them often enough that I can start to say, okay, backwards means times root 3 over 3. That makes this 14 root 3 over 3. Make sure you know what I just did. I did it already once. You should get it the second time. So now we can create a unit circle. It's a handy tool, that's all it is. A lot of people, I don't understand why we're learning unit circle. Well, this way you can memorize things without really trying all that hard. And trust me, that's a good idea. So, we're going to just do one of them in this quadrant. Here's our circle. The radius is 1. This is the point 0, 0. Therefore, this is the point 1, 0. Now this is 30 degrees. Why? Because it's an angle we like. 45 degrees and 60 degrees. This is 90 degrees. This is 0, 1. So we look at this triangle. I'll do the easy one in the middle first. And we say this length is 1. Go backwards, divide by root 2. That means the x-coordinate is root 2 over 2, like I just showed you. And the y-coordinate, since it's a 45, 45, 90, is the same. Doing this, this is 1. This is your 30 degrees, so this is your short side. The y value is 1/2. The other one is root 3 times that. This is turned around. If you don't know what I just did, you better figure it out. If you cannot put that together, you're in for a really tough time in trigonometry. Ask somebody, draw your triangles, figure out how a 30, 60, 90 and a 45, 45, 90 works. Because this is everything. And I don't go over these again. I don't even touch on 30, 60, 90s after this. It's really, really important you know what you're talking about. Just so we're all on the same page, this is 60 degrees here. This is 1. See where it takes you. Now, I'd like to put radians on there too. I know that pi equals 180 degrees. So pi over 2 equals 90 degrees. Hey look, 90 degrees, so I can label the radians, pi over 2. This is clearly 0 radians, but it's also 0 degrees, 360 degrees, because we're going to eventually go all the way around the circle. So that makes it 0 and 2 pi radians, because once around is 2 pi radians. Half of pi over 2 is right here, it's pi over 4. And with the same process of converting radians, get pi over 3 and pi over 6. Again, we did radians last lesson. If you don't remember it, you should review it. You need to know where these numbers come from, because your calculator knows that pi over 3 is equal to 60 degrees, and you need to be able to prove that. So we just put our radians on in green. So here's the whole circle. This is a significant chunk of time to put this on there. So what I'm going to do is open up another one, and then I would freeze the frame and figure out what you're doing from there. It'll take me a second to find it. That was not it. Nope. Must have saved it in a different file. So here's a filled out unit circle. Don't think I can quite fit the whole thing in. Good. If I were you, I would pause this and copy it down. So there it is. 30, 30 pi over 6, 45, all that stuff. Alright, now what just happened when we went over here? Well, first off, pi over 6, pi over 3, pi over 6, pi over 3, they all add up if you know what you're doing. Pi over 4, 3 pi over 4, they also add up if you know what you're doing. But notice the units, root 3 over 2, 1/2, root 3 over 2, 1/2. They're the same, except the x-coordinate is negative there. Alright, and the same thing follows down here. They're the same, except the x and the y are negative in the third quadrant. This is tricky stuff. I've done the unit circle before. I've gone through it in detail. It's in my trigonometry videos if you want to see it. But I would make sure you have this copied down, and then you must memorize it. If you try and get by, just, I kind of know it. It's going to get you sooner or later. Alright? So again, I'm not going to copy down here. It's very time intensive. If I were you, would take this, set a clock, and see if you can knock the whole thing out. The parts that I haven't talked about are, actually I might go through it real quick. The radians, then we have 1, 0, 0, 1, negative 1, 0. This is going to bother me because I can't do the bottom half at the same time. Root 3 over 2, 1/2. Root 2 over 2, root 2 over 2, 1/2, root 3 over 2. Now notice I'll ignore the signs for a minute. And I like to think of it as flip them X and Y, keep them the same. Flip them X and Y. It's just the way I do it. Now I know these are negative over here. While I'm here, let's do the degrees. 0 degrees and 360 degrees. 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, wrong, 135 degrees, 150 degrees, 180 degrees. Hey, let's do the radians. 0 and 2 pi radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. And that's unit circle. That's what we do. Gotta have it all memorized. Keep going. This is 7 pi over 6. This is 5 pi over 4. This is 4 pi over 3. This is 3 pi over 2. This is 5 pi over 3. This is 7 pi over 4. This is 11 pi over 6. Degrees. 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 310 degrees, 300, that's wrong, 330 degrees, 315 degrees. Notice how hard it is to keep things neat. Quadrant 3, quadrant 4, and see if I can remember this. Root 3 over 2, 1/2, ignoring the signs, root 2 over 2. Some people like to go and do the root 2 over 2s because they're easy to remember. 0, -1, 1/2, root 3 over 2, 1/2, root 3 over 2, root 3 over 2, 1/2. Negative, 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 negative. That's your unit circle. We're going to show you later how the cosine is x and the cosine is y, and by later I mean right now pretty much. This unit circle, this is 1. Cosine of 30 equals adjacent, that's this side here, root 3 over 2 from that, divided by 1. Just root 3 over 2. So what I say down at the bottom, what I mean when I say cosine is y, cosine is x and sine is y, is that you can now say the cosine of 120 degrees is negative 1/2. Sine of 3 pi over 2 is negative 1. It's just the y value. And that is the true power of the unit circle, although it does come in handy for lots of other things. You just start picking them right off. So again, all 6 trig functions for 5 pi over 3. Sine of 5 pi over 3, I happen to remember, is 1/2. Well, let's see if I'm right. 5 pi over 3, well, I was thinking cosine. My bad. Negative root 3 over 2. Cosine of 5 pi over 3, 1/2. Cosecant 5 pi over 3, negative 2 over root 3, rationalize it, negative 2 root 3 over 3. Secant 5 pi over 3 is 2. Again, I'm just flipping these. We've already done this. Tangent is sine over cosine, which is y over x. Negative root 3 over 2 over 1/2. You need to know that these two cancel and you get negative root 3. If you don't remember your 7th grade algebra, just don't forget Negative root 3 over 2 divided by 1/2 is what this says. And to solve that, we change this to times and we flip this over. They cancel and you're left with negative root 3. Make sure you know that. Boy, does it cause problems when people cannot handle fractions. Cotangent after the rationalizing is negative root 3 over 3. That's how we use the unit circle. You're going to get a lot of practice on this in your very near future. Memorize it, have it handy, do all the problems so that when you are done you have it locked down. Good luck, and as always, happy mathing.